Before we explore the declaration, it's essential to grasp the significance of what's at stake. The Large Hadron Collider, LHC, operated by CERN, marks a monumental accomplishment in scientific progress. Spanning 17 miles, this sophisticated array of superconducting magnets stands as the largest and most powerful particle accelerator ever created. It serves as a symbol of human creativity and the extraordinary achievements we have made in understanding science. Astonishingly, the LHC is capable of recreating the conditions that existed during the very beginning of the universe. However, as we venture into the cosmic unknown, a crucial question arises. Could this machine, which aims to reveal the universe's deepest secrets, also expose us to unforeseen risks? Founded in 1954, CERN is one of the world's most respected scientific institutions. With 23 member nations and a vast community of researchers, it serves as a center for collaborative research and groundbreaking discoveries. Although the LHC is its flagship project, it is just one part of a wide range of particle accelerators and experiments. Think of it not as a racetrack for cars or horses but as one for subatomic particles engaged in a high-stakes race to test the limits of speed, precision, and the very essence of space and time. Inside the LHC, protons are accelerated to speeds nearing the speed of light, mimicking the energy levels that were present when the Big Bang occurred. The resulting collisions reach temperatures much higher than the core of the Sun. A system of magnets guides the protons along their paths, while advanced cooling systems maintain the magnets at temperatures colder than outer space. These collisions are intentionally staged at 4 distinct points within the accelerator, where specialized detectors, ATLAS, CMS, ALICE, and LHCb, gather data. Each detector has a unique function, providing a different perspective on the aftermath of these high-energy impacts. Together, they act as immense cameras, capturing the aftermath of these collisions. Researchers meticulously examine the debris to identify elusive particles like the Higgs boson, often referred to as the God particle, and other phenomena that might illuminate the fundamental building blocks of the universe. By zooming in on subatomic particles, researchers aim to understand the very structure of the cosmos. Nonetheless, each new discovery at the LHC raises even more questions. The LHC is not just a machine, it represents humanity's unwavering curiosity and our relentless pursuit of knowledge. It symbolizes our desire to understand the forces that shape our existence. But as we expand the boundaries of the unknown, we must confront the moral and existential dilemmas and dangers that may arise from probing the unknown. Could our quest for knowledge unleash powers at CERN that we cannot control? The limits of human understanding are being stretched to their utmost. A disturbing realization has emerged, one that has unsettled even the most seasoned scientists. Brian Cox, a former CERN researcher and a highly regarded figure in particle physics, recently made a chilling statement that has both intrigued and alarmed people across the globe. Cox revealed that the LHC's purpose is to simulate a small-scale version of the Big Bang, essentially, a mini Big Bang. He elaborated on the immense potential of the LHC to uncover groundbreaking discoveries, such as figuring out how dark matter works, a substance that constitutes much of the universe. The possibility of harnessing the fundamental forces of the universe is undoubtedly exciting, but it also comes with significant risks. The mini Big Bang is not just a theoretical idea, it is a real phenomenon that occurs within the LHC. The collider reproduces conditions of extreme heat, pressure, and energy, mirroring the environment at the universe's birth. It's as if we are witnessing the birth of time itself. However, with such vast power comes immense responsibility. What if something goes wrong? This concern is not a new one. Back in 1978, Russian physicist Anatoly Bugorsky had an experience that forever altered the course of his life. While working with the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction caused a proton beam to unintentionally cross his path. The beam, traveling at unimaginable speeds, pierced his skull, entering from the back and exiting through his nose. Though struck by a flash of light brighter than 1,000 suns, Bugorsky remained conscious and walked to get medical attention. The aftermath was both astounding and terrifying. He lost hearing in one ear and experienced partial facial paralysis. Despite the severity of his injury, he retained his cognitive functions and continued his scientific work. Bugorsky's experience serves as a grim reminder of the power and potential hazards of particle accelerators. The dangers of devices like the LHC should never be underestimated. Some scientists have expressed concerns about the possibility of unforeseen reactions that could alter the very fabric of reality. For instance, there are fears that the LHC could potentially create a miniature black hole. Black holes are regions of space where gravity is so intense that not even light can escape. These destructive forces exist at the edges of the cosmos, and the idea that the LHC might create even a tiny black hole both inspires and frightens at the same time. Could such a black hole grow uncontrollably, ultimately consuming the Earth from the inside out? CERN researchers have attempted to reassure the public, asserting that any black hole formed within the collider would be highly unstable and would disappear almost immediately. Still, the mere possibility of such an occurrence has sparked considerable debate and concern. To comprehend how the LHC could create a black hole, it is important to understand the fundamental mechanics of a particle accelerator. When protons collide at nearly the speed of light, the energy released is so immense that it can distort the very fabric of space and time. To visualize this, imagine a tightly stretched trampoline with a heavy object dropped onto it. The fabric sways, and if the object is heavy enough, it can create a depression deep enough to pull anything nearby into it. This analogy provides a glimpse of how the LHC might affect spacetime at a quantum level, where the laws of physics become unpredictable. A theory suggests that extra dimensions beyond the familiar 3 dimensions of space and 1 of time might exist. If such extra dimensions do exist, the LHC might have the capacity to access them, potentially forming a gravitational well that leads to a tiny black hole. The possibility of this has attracted the attention of renowned physicists, including the late Stephen Hawking. In his writings, Hawking cautioned that the Higgs boson might become unstable at high levels of energy, possibly triggering catastrophic events such as vacuum decay. Sir Martin Rees, a distinguished astrophysicist, also raised alarms about the LHC's experiments. In his book on humanity's future, Rees acknowledged that while the chances of such an event were low, even a small probability warranted serious consideration. The stakes are incredibly high, and the margin for error is razor-thin. CERN researchers have conducted numerous simulations and analyses, taking every measure to ensure the safety of their experiments. Brian Cox himself has addressed concerns surrounding the LHC, emphasizing that stringent safety protocols are in place. When protons collide at nearly the speed of light, they momentarily break through the conventional barriers of physics, creating a window into the unknown. What might we discover beyond this threshold? Could the LHC inadvertently lead us to a reality-altering breakthrough or an unforeseen catastrophe? Some theorists propose that if extra dimensions exist, the LHC might produce microscopic wormholes, tiny bridges between different parts of the universe or even parallel realities. This idea, though speculative, has fueled both scientific inquiry and public imagination. If we were to access another dimension, what might we encounter? Would we be alone, or could there be entirely new forms of existence beyond our comprehension? While most mainstream physicists dismiss fears of catastrophic events, there is no denying that each experiment at the LHC pushes the limits of human understanding. We are venturing into domains where the laws of physics as we know them may no longer apply. If the universe is a vast puzzle, the LHC is our most powerful tool for piecing it together, one collision at a time. Despite concerns, the LHC has already yielded extraordinary discoveries. In 2012, researchers at CERN confirmed the existence of the Higgs boson, a fundamental particle that explains why matter has mass. This discovery reshaped modern physics, proving that our theoretical models of the universe were largely correct. However, it also raised new questions. What other unknown forces are at play? Could there be particles beyond the standard model, waiting to be uncovered? The next frontier for the LHC involves investigating dark matter and dark energy, two of the greatest mysteries in cosmology. Dark matter is believed to make up about 27% of the universe, yet it remains invisible and undetectable by conventional means. Scientists hope that high-energy collisions at the LHC might produce particles that could provide insights into this elusive substance. At the same time, researchers are also exploring the possibility of quantum gravity, the idea that gravity itself may have a quantum nature. If true, this would revolutionize our understanding of the cosmos, potentially bridging the gap between Einstein's theory of relativity and quantum mechanics. As we continue pushing the boundaries of knowledge, the LHC remains both a beacon of scientific progress and a source of existential contemplation. Are we on the verge of unlocking the universe's deepest secrets, or are we merely scratching the surface of an ever-expanding enigma? Only time will tell what the next chapter of discovery holds. With energies never before seen on Earth, they might create ripples that probe these hidden dimensions. While this remains speculative, it shows the allure of the unknown. The potential of discovering other dimensions continues to captivate the public, even though most scientists remain skeptical that the LHC will open a portal to another universe, or to something far more terrifying. Should we be concerned about the risks associated with the LHC? It's easy to get caught up in sensational headlines and fears of cosmic catastrophes. However, the reality is that scientists at CERN are fully aware of the potential risks and have taken numerous measures to ensure the safety of their experiments. They continuously monitor and assess their work with the highest level of diligence. The potential benefits of their research, such as unraveling the secrets of dark matter, discovering new particles, and deepening our understanding of the universe, are truly remarkable. These breakthroughs represent a significant leap forward in human understanding, but they come with inherent risks. As with all groundbreaking scientific advances, the experiments conducted at the LHC present profound ethical questions. Could the creation of exotic particles or the exploration of extreme energy conditions lead to unforeseen consequences for our planet or even the very fabric of reality itself? These questions cannot be neglected and require careful consideration in the context of the broader implications of scientific progress. In conclusion, the Large Hadron Collider is a monumental achievement in human ingenuity and curiosity. It has already led to groundbreaking discoveries in particle physics, providing insight into the fundamental workings of the universe. Yet, as we explore these uncharted territories, we must remain vigilant, aware of the potential risks involved. The pursuit of knowledge is one of the most ambitious endeavors of humanity, but it is not without challenges. The LHC stands at the forefront of scientific exploration, where theory meets experimentation and where the foundations of our understanding of the universe are being tested. The journey of discovery is never without peril, and the LHC is no exception. It pushes the limits of physics, seeking to reconcile the fundamental natural forces and answer age-old questions about the origins of mass and the nature of dark matter. However, as we continue to explore these frontiers, we must consider the profound ethical and existential dilemmas that arise from manipulating the forces that govern the universe. The risks of unintended consequences, whether for our planet or the very fabric of spacetime itself, remain a challenge that demands thoughtful reflection. Nonetheless, the pursuit of knowledge is still one of humanity's most noble endeavors. The LHC's experiments, while risky, offer us a glimpse into vast, unexplored realms of science. As we stand on the brink of discovery, we must approach this journey with both ambition and caution. The LHC represents not only the pinnacle of human technological achievement but also a powerful tool with the potential to reshape our understanding of everything, from subatomic particles to the grandest cosmic phenomena. With each breakthrough, new questions emerge, opening fresh avenues for exploration and thought. The path of scientific discovery is uncertain, but it holds the promise of revelations that could redefine our understanding of the universe, our place within it, and the very laws that govern reality. One of the most profound aspects of the LHC's experiments is the intersection of theory and reality. For decades, physicists have grappled with understanding the forces that govern the cosmos: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The ultimate goal has always been to unify these forces into a single, cohesive construct. The LHC has been instrumental in providing experimental evidence and insights that bring us closer to this elusive goal. Its work not only enhances our understanding of particle physics but also holds the key to uncovering the fundamental truths of existence itself. The ethical dilemmas tied to these experiments are considerable. Yet, the pursuit of knowledge has always carried risks. But when those risks involve altering the very fabric of space and time, the stakes become immeasurably higher. Could a single experiment at the LHC inadvertently trigger an event we don't fully understand, leading to consequences beyond our ability to predict? This is a question that scientists, philosophers, and ethicists continue to explore. As we delve into these uncharted realms, we must remember the responsibility that comes with harnessing such immense power. Despite the potential dangers, few would argue against the pursuit of scientific progress. The rewards, new technologies, advances in medicine, and a more in-depth understanding of the universe, are immense. The discoveries made by the LHC thus far have already transformed the scientific landscape. From the Higgs boson's identification to advances in our understanding of dark matter, these achievements have extensive applications beyond just physics, influencing other disciplines that rely on this foundational knowledge. As we continue to push the boundaries of possibility, the LHC serves as an example that science is never without uncertainty. No experiment is entirely risk-free, and the LHC, as grand and powerful as it is no exception. But there is always the possibility of monumental discoveries. The LHC symbolizes humanity's relentless pursuit of knowledge, our search for answers to questions that have puzzled us for centuries. Ultimately, it is this curiosity that drives us forward, the desire to understand the universe, to peer into the depths of space and time, and to uncover the forces that govern everything from the tiniest particles to the largest galaxies. The LHC may carry risks, but it also represents the zenith of human achievement in particle physics. It is a tool that enables us to explore the most profound questions about existence, challenge the very laws of nature, and seek answers to the mysteries that have eluded us for millennia. Whether or not the LHC will lead to the discovery of new dimensions, open portals to parallel universes, or trigger unforeseen phenomena remains uncertain. What is certain, however, is that it is one of the most powerful instruments ever created, capable of unlocking secrets about the universe that were once thought to be beyond our reach. The potential for discovery is boundless. As we journey further into the unknown, we are reminded that science is a journey, one that requires both boldness and responsibility. The experiments at CERN continue, and we must stay alert to the possibilities, the risks, and the enormous potential for new understanding that lies ahead. The LHC, while embodying the cutting edge of modern science, also reflects our deeper quest for meaning and understanding in a vast and mysterious universe. Each new discovery brings us closer to a fuller comprehension of the forces that shape our existence.